Have you ever wondered if electricity can be produced using water? It's a bizarre concept, something that is seen as unthinkable to most, but it is technically possible to do with the right circumstances. An example that we would like to present is watermill. The apparatus uses the concept of potential and kinetic energy to produce mechanical energy that will be used in creating hydroelectricity.
Before we present our final project, we must first have a refresher on how the aforementioned concept works. Potential energy is the stored energy that is quantified by the position, properties, or force acted upon an object. The way it works is that the higher the position of the object in the air, the higher the potential energy.
For example, the position of a ball in the air would determine the amount of the potential energy it has. The higher the ball, the higher its potential energy. Another factor is how much force is acted upon by the ball. The higher the force, the higher the potential energy.
The quantities of potential energy would then be converted to kinetic energy the closer they are to the surface, with the maximum quantity being the initial quantity of the potential energy. This is if the potential energy is based on the height and gravity. Kinetic energy, the measure of an object because of its motion. It depends on the speed of an object, which depends on the potential energy. And as the object gets faster, thus getting closer to the surface, the kinetic energy increases.
The measure of kinetic energy is at highest when the ball hits the point of the surface. How high the ball would bounce would depend on the quantity of kinetic energy the ball has. And once the ball bounces, kinetic energy converts to potential energy once again and vice versa until it doesn't bounce anymore. This exchange is called mechanical energy, and this would be demonstrated in the watermill.
Mechanical energy is the ability of an object to do work. It is what you get when you get potential energy and kinetic energy come together. It is essentially the exchange of potential and kinetic energy as well as energy of the mechanism that is powered by potential and kinetic energy.
Presented here is our replica of a watermill. The apparatus activates when we apply water to the tank. The tank has a hole and a straw inside of it that the water uses as a passageway to activate the water wheel, making it spin. As the water wheel spins, the DC motor connected to the water wheel will activate as the wires that are connected to the DC motor are connected to the LED. So as long as the water wheel spins, the LED would continue to light up.
The concept that starts this whole apparatus is the potential energy. The height of the straw that water drops from is the source of potential energy as it converts to kinetic energy once the water hits the water wheel. This then activates the water wheel as it spins. This is mechanical energy, the ability of an object to do work as presented by the water wheel.
Potential and kinetic energy have always been a fundamental concept of our physical world, as it has played its role in countless phenomena and machinery. From single phenomena like throwing and catching, dropping and even shooting, to simple mechanisms like seesaw, pendulum swings, and even the water wheel that we just presented. It is essential that one would study and master this concept, especially if they're going for a STEM course, to understand many more advanced physical phenomena in this world. Preferably for the engineers who need to have a greater understanding of physics.
Energy conservation, potential and kinetic energy are essential to power certain machinery without using non-renewable resources as power resources. As proven by the watermill, one can harness the power of energy conservation when they have a fundamental understanding of this concept.
Transportation. Mechanisms like roller coasters rely on potential and kinetic energy to move around the rails and produce velocity.
Engineers who master the concepts of classical physics can use their experiences to design machinery that require potential and kinetic energy in their calculations. Understanding potential and kinetic energy will help you simulate and visualize the impact of certain mechanisms, such as cranes, turbines, roller coasters, pendulum clocks, and so much more. Understanding the fundamentals will help aspiring engineers design their machinery and builds.
Sports like basketball, volleyball, tennis, and badminton emphasize their use of potential and kinetic energy to keep the important objects like balls and shuttlecocks in motion.
Before we end our video, there is one aspect that I would like to explain that wasn't presented in our output, and that is the absence of the LED. You see, we were supposed to present the LED as the element that represents electricity being generated, which was the whole point of our project. However, things didn't go as planned as the DC motor wasn't spinning fast enough. When we experimented with the DC motor, it worked when we flicked the item with our fingers, but it didn't work with the spinning water wheel. We've tried using a bottle cap wheel instead of a spoon wheel, but they all fell short. They required a faster speed from the water wheel which our output couldn't provide. The LED wasn't working, so we decided that we could present the water wheel without it.